Hello and welcome to Technical Utkranti, and today we are going to make this third video on heap data structure. In this video we will see how we can find kth largest element using heap data structure. Why are we using heap data structure? Because in heap one could insert an element in an appropriate order in just log of n time complexity, and one can delete the element from the heap maintaining the order in just log of n time complexity. So let's get started with understanding this concept, and before that let's have a look at the thought for the day. Alright, so let's see what is the intuition. Whatever the elements that we are given with, we'll create a heap out of it. Then this is going to be the max heap. In max heap, the highest element is at the top. So if we have to find the first highest element, that is already there on the top. If we have to find the second highest element, we need to delete the topmost element and heapify the heap, and here we have the second highest element at the top of the new heap. Similarly, if we have to find the kth largest element, we need to perform deletion operation on heap k minus 1 times, and the topmost element would be there, which will be the kth largest element of the original heap. So I hope you understood the intuition. Let's see it with the help of some visuals. So I have these many numbers and I have created heap out of it. As you can see, the highest number is at the top. Alright. To get the largest element, we delete the topmost element. When we delete the topmost element, we replace the topmost element with the lowermost element, and lowermost element goes away. So heap becomes like this. But this is not how a max heap looks like. So we need to heapify it. When we heapify, what we do? This is the parent element, and we take its two children, and whichever is the highest children, we exchange parent and child with that. So it looks like, so 1 will come here and 5 will go here, and similarly this will compare with the 2 of its children, and 3 will come over here and 1 will go over here. So finally heap would look like this, and at the top we'll have the highest element, which is like the second highest element of the original heap. So I hope you understood the intuition with visuals as well. Now let's dive into the code and understand how it is implemented. So this is the main function we have. We have been given a list of numbers and we need to find the kth largest element. Alright. So in order to create a heap, what we do is we find the number of elements that we are given and we create an array with one element extra than the number of elements that we are given, because at the 0th index we insert nothing when we create heap. Alright. Now we start inserting numbers into the heap. How are we doing that? We iterate on, or we pass through the nums list, and we increment the index of the heap where the element would go. We place the element in the heap, so ARR is basically heap, and we heapify. Alright. Okay, so what does heapify do? We have already seen in the previous video. So you are given the index at which the element has been inserted, and we find its parent index. If the element at parent index is smaller than the element at which the element is inserted, the current element is inserted, then we swap them and we call the function recursively for the parent index now. Okay, and similarly this would go on until index is less than equal to 1. Alright. Okay. So in this way we'll create a heap, and here we have heap with us. Now in order to get the kth largest element, we need to delete k minus 1 elements from the top. So how we delete? We replace the topmost element element at index 1 with the element at the max index. Okay, we replace that and we make the element at the maximum index as none, and maximum index is reduced by 1, right, because you've deleted one element. This basically is now pointing to the elements in the heap, and once the deletion is done, we have to do heapify after deletion. All right, so let's look at the code of it. All right, so we are being given the heap, the length of the heap, and to begin with, the index is 1 at the top. Okay, we find the left and the right index. Now we know that left index is less than the right index. So if the left index is greater than length, so right index would naturally be greater than length, right, because right index is greater than left index. So we don't need to do further comparisons and we return. In another case, when left index is equal to the length of the heap, then it is the left index with which we need to compare the parent index, right? And if the parent element that is there at the top, that is smaller than the left child of it, then we swap it, because in maximum heap the topmost element should be the highest. So this is currently the topmost element, right, and we return. In another case, so what we'll do, we'll compare two children of the parent and find out the child which is bigger. All right, we note it as the swap index. So either the left child needs to be swapped with the parent or the right child needs to be swapped with the parent, and that is stored in the swap index. And then we compare the parent element with the element to be swapped, or the candidate element to be swapped, and we swap it if the element at higher location in heap is smaller than the element in the lower location of the heap. And once this swapping is done, we again do heapify recursively, and as you can see, this is the return condition. Basically these two are the return condition. When the left index is either greater than length or equal to length, we don't need to do further more comparisons other than this one, right? So heapify after deletion is also understood, and finally we return the topmost element. All right, so let's submit it and see if our solution is accepted. Yes, it is. So I hope you understood the question, the approach and the code. If you did, please give it a thumbs up and subscribe to my channel. Thank you. Bye bye.